Hello, everyone. My name is Paulo, Lyra. I am from Moffitt Cancer Center here in Tampa, Florida. And today I'm here to show how to go through the Galaxy PyCaret tutorial material. And my goals are actually three goals. The first one is to explain the origin of this tutorial, how it was conceived. And the second goal is how to use PyCaret to obtain results, how we leverage this tool. And the third step, I think it's the most important one, is make you comfortable and aware how you can bring your own data sets to build the model you need for your project. So let's get started, and I'm gonna show you my screen so we can talk through all the materials. So probably at this point, you're very comfortable using Galaxy. So we are using the US server, use galaxy.org to run this job and build the models. I want to mention before we continue a second option. This is called cancer.usegalaxy.org. This is, I must say, not official Galaxy, but it's a server of Galaxy that we run in the lab. So also I'm a member from Dr. Gag's lab, and we have this server where we use as a test for the tools that we are developing in the lab. So you also might consider sometimes looking the tools around here to see if something new and interesting you. But anyways, we're gonna stick to the US server as the main one. So as I mentioned, I'm here to talking about the LORIS tutorial. If you type in the Galaxy training right here, training.galaxyproject.org, you're going to find out these two materials that are posted. The first one, it's the hands-on, which is the step-by-step how you're going to accomplish to build this model. Here I'm bringing a lot of information about um, how this was built and some additional information about the data set and so on. We have a second option. This one is more short, which is the slides. Here are more concise, and you can go through this material on your own pace. I'm gonna stick to something more natural to give you the perspective how we can run this without sticking to the material. You can read that by yourself. So first of all, I think I need to mention the origin of this work. It's from this paper right here. Uh, this paper is from 2024, published by Nature Cancer. This, I'm gonna give you an overview of this paper, which is they decided to build a model, a machine learning model, based on the uh, clinical data they have for patients. So what they are trying to achieve here in this paper is to separate into two categories of patients. One that can respond to checkpoint blockade therapy, and the patient that is not going to respond to this therapy. So distinguishing between those two patients is really important because you can decide which chemotherapy path this patient can go, save time, save the patient's life. So it's a really interesting paper. And if you uh, search for the GitHub, they have all the information posted in this repository right here. So they have the inputs they use and the code and everything that was generated in the paper. So I went here. So now I'm trying to explain the homework I did. If you download this data, you're gonna see that they have the sample ID for each patient, the clinical information for each patient, and the last thing here is the response. Not this one, but this one. Okay, sorry. So here we're gonna have the response of the patient right here. Sorry. Okay. So one thing you might be aware at this point when you're dealing with machine learning is the fact that sometimes it's better to have numerical classification than names. So here, cancer type, it's colorectal, melanoma, etc. Those names are not informative when you're running machine learning. So there is one approach, call it one hot encode. So they transform the cancer type into zeros and ones. So each cancer type, it's now a number, present or absent. So for example, here, if it's colorectal would be this cancer type 1, for example, then here will be a 1, and so on and so forth. So we don't know exactly how to map this at this point, but you transform that. That's why you're seeing those columns right here. Each cancer type was transformed into numbers. But anyways, you have the other informations right here. So this is the first step of this tutorial, getting familiar with this LORIS, which is the name, how they named the model, and the data set. So the data set, it's split into tabs right here. So you can see there is different data sets. For the purpose of this tutorial, we're gonna use only the first two data sets. You can play around with the other ones. So Chowell train and Chowell task is the ones that we're gonna work with at this point. Okay, so this is how we get familiar with the data sets. And again, I'm gonna point to here if you wanna be more familiar with the nomenclatures in the headers, so you can read what that means: tumor mutation burden, systemic therapy history, albumin, and how this plays a role in the patient's um, in a patient's life. So, but again, let's move on. This is not the main thing that I want to show. So now we are trying to mimic this model they create. And if you look the model they created, they use tons of code to generate this model. I'm going to show you quickly. This is the number of files to generate the models. There are several models, I must confess here. It's not just one model, but as you can see, they are doing some plot, violin plot, for example, a rock AUC plot. So things are moving here to show how the model will behave and how good is the model by those codes right here. One example here, let me see if I can pick one. We can see the evaluation, for example. They have the models right here, how they're gonna evaluate. So they have different models being built, and they're gonna compare those different models to see which one is the best model to uh, uh, separate the patients from the classify the patients into who is going to respond and not respond. So this is the code they generate. It's a lot of code to generate, and with this tool that we want to show you, Galaxy PyCaret, things are going to be pretty much easier than that. So let's see. There are two approaches here. So the first approach is using Zenodo. Zenodo is where we have the data sets stored, ready to go. So you can come here and just copy those URLs. So Control C, come here to load your own data set. You can click here. You also have the button here on the left if you don't see it. Let me do something first. I'm going to, okay, this is a new history. If you don't have a clean history, you can click on this plus button here, create a new history, and create a new history for this work. So here I'm gonna label as LORIS. Today it's May 6, 2005. All right, so just like keep things organized. So I'm gonna click here. Again, if we can anywhere is fine. Then since I have the files on Zenodo, I just paste and fetch here the URLs. So those two start and uploading those two data sets. However, if you're more familiar with coding Python, you're comfortable and you want to see more details because this data set, it's not exactly how it's to the raw data set needs to be pre-processed. So if you are interested to see those pre-processing steps, which is this preparation right here, extraction, selection of the features, the truncation, and the one hot encode cancer type, you can go to this link. It's here at the slides and also here present in the hands-on tutorial. So it's Jupyter Notebook. So those two places you can go and click. Now you're presented to this doc store, which is a tool to store information. And you can click in this Google Colab. And now you can see the Python code that is going to generate exactly what we need to prepare pre-processing the data sets. So if you click the buttons right here, you're going to run the codes, just run everything. It's fine. So we are just pre-processing. I'm not going through all the details on this code. I hope if you're interested in this part, it's because you're comfortable with Python code and you're going to see how I'm doing things with some functions, setting up some functions, and then the final code that is going to produce everything. Okay, I don't have the file here, but let me see, where is this error coming from? Oh, I forgot to execute the path. Okay, sorry. All right, so now everything should be fine. And if you look here, it's already downloading everything that we need. So save as. I'm gonna save here at the desktop, and that's it. We have all the data sets downloaded. All right, this is another option, just to give you the glance that you can change things here if you want to play around. But let's go back here. So data sets are in place. Let's take a look how the data set looks like. So columns and rows, each patient's hot encode for the cancer data type. We have in the last column the response. Okay, everything looks good. Now let's select the tool. So if you click here in the tools, um, scroll down here in machine learning. So the big topic is statistics and visualization. You can click here in machine learning. Then you have different tools. At this moment, we're going to use PyCaret model comparison. So select PyCaret. So now it's just a matter of setting up everything. As you can see, this tool, it's really simple to run. Only thing you need to do is, let's see, here it's requiring the training data set. Okay, so we have the training. It's right here. So this is the train. Now it's asking us to the test data set. All right, we have the test, so we split the data. What else? So now it's asking which column we are targeting. So we are targeting response, right? So it's the last one. So at this point, I hope you're going through all the materials of machine learning and more familiar with regression and classifications. Since we have zeros and ones for response and no response, we're going to categorize in two. So this is a classification task. Sorry. Now we have a couple of options here. We don't need to select exactly one model we want to test on. We can select, not select, and the tool is going to try to fit this data set into all different models. This is one option. It's what is the good thing here? If you don't know exactly what model you're looking for, you can test different models and pick the one that is best for you. This is why it's good, this tool. If you're like, okay, I want this specific model to be built, then you can go here and select, oh, I want a decision tree classifier specifically. So the tool now is going to train and test the model for this particular uh, model. So since we are just uh, seeing how this tool looks like, we are not going to select anything. Random seed is just to set up the experiment to be to concerning reproducibility, stabilize things in the machine. So we don't need to change this. We also don't need to set up anything else to customize. We just want to give it a try in this tool and see if we can reproduce the LORIS model. So I'm going back to the materials, the our not this one, the slides. I think the slides have more uh a better comparison of those two. So again, everything that I just said, it's here on the slides. You can follow through if you're looking for more details or something that I didn't say. I'm just want to give you this nice and clean view that it's really fast to come with your data sets in table and run the model. So at the end, I hope to get a model because everything is same setup. I can compare what a PyCaret tool generate as a model result to the original, which is Chang 2024, the LORIS publication right here, right? So comparing the numbers, so we have accuracy of our model as 0.8, which is better than the one presented by Chang et al. They present 6.8. So overall accuracy, our model performed better. Broad AUC, our area under the curve, we are around 0.75, which is also higher than the one presented by Chang et al. Model. Not that high, but yes, kind of similar. Here we are stumbling a little bit on the F1 score, which is the precision and recall balance. We are just down from the one they present in the paper. And the Matthew correlation coefficient is also a little bit down. But again, the models are kind of different, but they are doing exactly the same job. So with this, we want to pinpoint to you that this model that was generated with low code and really simple click of buttons, you're ready to go to build models that are consistent. Uh, we are enforcing best practice here because the models are generated in the reproducible you're going to see that everything is stored, so you can share this information to anyone. So since this is running, I'm going to skip to one of my uh, jobs that are already done. It's the same setup. Pretend that this is just, I think, let's see how long this took to run. So I'm clicking here and in this information icon right here. And if you scroll down, you're going to see wall time. What is it? Uh, oh, right here. So wall clock. So 8 minutes to run this job. So probably 8 minutes, we're gonna have the other one that I just trigger done too. So everything is here. So this first output right here is the model files. If you want to save and download this, now you have the files that generate this model in H5 files uh, ready to go, which is really interesting if you want to deploy this model in a different environment. And here, remember, you're also looking for figures and a way to read the metrics and everything else. So if you click in this eye, you're going to see a report. Here, you're going to have different tabs. Each tab is going to show you different metrics and different uh, perspective and behave of the model. So the first one I want to show you, and the most important, is the best model that we picked. So the setup parameters here is the second layer, which is the hyperparameters. And again, I'm going to point you to the hands-on um, right here. In this section, I'm going to go through every single hyperparameters if you want to dig deep into it so you can read each parameters and how they behave, why it's important is just right here. Just take your time. I think I explained the concise way to you. Um, and here, remember, we just trained this number of models to pick the one that performed the best. So that's why this tool is amazing, because it gives you tons of models at one click, and you don't need to go through all this burden to writing these codes and evaluations and everything. We are just taking care of everything that this code is doing. We are just doing this in the tool. So that's why this PyCaret um, model comparison tool is awesome. So at the end, we also find the logistic regression. So if you look at the numbers, they are kind of similar, the ones that I showed you before. So much more information here. I hope if you're looking to building models, building different classifications models or regression models, you can bring your own data sets, just tabular data, target column, and you're good to go with this tool, not hustle at all. I hope you enjoyed. I hope you have a good glance of how this tool can be trusted in the concrete case as the one we compare what we build to the published model in a big journal, Cancer Nature. So thank you. See you next time.